Hi, in this video I'll give you a quick overview of the NeoDen-4 pick-and-place machine with computer vision-based alignment. A few years ago I bought the NeoDen TM240A pick-and-place machine. This is one of the most popular low-cost desktop pick-and-place machine, and it has worked pretty well for 3 years. I've made thousands of boards with this machine. But because this doesn't have computer vision based alignment, it's pretty limited. It can't really do fine-pitched chips, and it has only 27 feeders, which are not really sufficient for me. Recently, NeoDen has released a new version of the machine called NeoDen-4, and this machine comes with computer vision based alignment. Specifically, it has a down-facing camera which can identify fiducial points on the PCBs, and it also has an up-facing camera which can align components. On top of that, it has up to 48 feeder slots, so this is more than sufficient for me. And also it comes with the PCB feeder, this conveyor belt system, which makes it really easy to feed PCBs into this machine. So I'll give you a quick review of how to run this machine and my general experience with it. The machine came in a big wooden box that weighs about 70 kg. It's very well packaged. It wasn't entirely clear to me how to open the box initially, so we pried open the top cover, but it actually turns out that there are a few screws at the bottom of the wooden box, and all you need to do is to untighten these screws, and then you can easily open the box. You can also purchase this work table, which is specially designed for the machine. The machine comes with a built-in computer which I think runs Windows XP. So the component feeders are arranged on the two sides of the machine. On the right-hand side, these are all 8mm tape feeders, and I think there are about 19 or 20 of these. And then on the left side, there are some additional 8mm feeders and some 12mm, 16mm, and 24mm. And these component feeders, when you order the machine, you can customize them, and you can basically tell them how many of each size feeder you want, and they can customize it for you. So on the left side here, it's a platform that you can place, tray matrix components like chips, and including you can design your own tray matrix. Like this is a 3D printed tray matrix I designed for the ESP8266 Wi-Fi chip. You can actually also put PCBs onto this platform. So like you can use these fixture tools to fix a PCB here, and that way you can pick and place components onto the PCB in this area as well. And on the right here is the PCB conveyor belt, which you can use to automatically feed the PCBs. There's also a vibrator feeder here which can fit 5 tubes. So these are really convenient for tube packaging. So now I'm going to turn on the machine, and you can see the initialization process. So when I power on the machine, the computer system will start to boot, and this machine has a built-in air compressor, so it's a little bit noisy, but it's pretty convenient because then you don't need an external air compressor. So that makes the machine remain compact. And so you can see the system has booted up, and then the pick-and-place head is going to do some initialization and alignment. So this is NeoDen's software interface. It's pretty minimalist. By the way, so I just out of curiosity, I changed it to Chinese language, and apparently to change it back to English, I have to ask the manufacturer for a password, which I haven't got. So, for now, I'm just stuck with the Chinese language, but hopefully, most of these are pretty intuitive and easy to recognize. So this is the first tab, which shows the pick and place files, and here is menu testing. So here is where you can sort of test all the components of the machines. So now let me go into a specific PCB, and you can see how to edit the pick and place file. So I'm going to choose the Open Garage board, which comes with a 2x2 panel. So I go into the editing interface. So this is the first tab. This is called the PCB information. So for this, because this panel I didn't leave enough margins on the side, so I didn't want to use the conveyor belt because that would tend to smear out some components on the side. And so I chose to use the fixed tray form. Now this section here defines the fiducial points, or they call it the PCB marks. Because I'm using a panel, I'm going to just use two fiducials, one on the lower left, one on the upper right. And these don't have to be, proper fiducial points. These can just be some landmarks on the PCBs. So let me check the first fiducial. So you can see that the camera moves to the first fiducial, which is roughly here. So, you can move around and you can pick a different fiducial if you want. But, when you're getting fairly close, you can use this button to snap onto the fiducial. So it's going to use computer vision algorithm to try to identify the center of that landmark, and then lock onto that. And then you can, save it and return. And let's see, the other fiducial is around here. On the right hand side, this big table defines the pick and place position XYZ coordinates of each component, the rotation angle, and you can also define the packaging and the component specification, but these are, I think, just for your information. The machine doesn't really use these packaging information. What's important are the XYZ coordinates, rotation, and also which pick and place head. So there are in total 4 heads you can use, so it can simultaneously place 4 components at the same time, and also which component feeder. So these XYZ coordinates, you can obviously visually define them by just going into the PCB and locate every component, and then pick the location and confirm. But you can also import from the spreadsheet. So I wrote a Eagle CAD script file, which allows you to easily export the XY coordinates from existing PCB design. So I have shared that script on my website, and you can go and download that script, and that makes it pretty easy to import these XY coordinates. And then so about the component feeders, now this second tab here, this basically defines the feeder configuration. So here you can say you can enable certain feeders and leave the rest disabled. You can define, for each feeder, which pick and place head are you going to use. Some of these, like this one is matrix tray, so you can define like the matrix tray configuration. and this one is for the CH340. So this one is a vibration feeder. So this component, and you know, again, you can basically you can customize the pick and place location. You can use the visual aid to help you identify where it should pick the component, and other things like the height of the component. And this selection box allows you to choose whether you want vision correction or not. So the default is correct, and you can also choose not to correct. Like if you know this is some capacitor or resistor which, you know, like a little bit error is fine, then you can choose to not correct, and that will speed up the pick and place. Okay, so now I will start a pick and place session. So I'm going to start with stepping so that you can see step by step what the machine is doing. So I'll start, and then as you can see, the first step is it's going to do the fiducial recognition. So now it has recognized both fiducials, and then the next step is the first and the second component. So this is the CH340G USB serial, so this is doing vision-based correction, and then placing, and vision correction again. So I'm just going to let it run continuously now. Now some of the components like capacitors and resistors, you know, they're pretty tolerant to small errors, so I have skipped the vision correction for those small components. And this last component is the buzzer, which is a fairly large component. So here is the result of the pick and place. As you can see, it looks pretty good. The components are all quite well aligned, and I haven't quite figured out how to use the matrix tray yet. So the ESP8266, the largest chip here, I'm gonna have to place them by hand for now. So in the second example, I'm going to show you how to use the PCB conveyor belt to feed the PCB. So in this case, you can set the machine to identify the front edge of the PCB, and this way it can automatically feed the PCB without having to fix it onto this platform. So I'm going to click on the PCB feeding this button, and you will see what happens next. So you see that from the vision camera, let's see, from the vision camera here, we can see that it basically identified the front edge of the PCB and stopped there. Okay, so now let me start with this pick and place session. And this board is the open sprinkler DC powered expander and arranged in a 3x1 panel. So again, I'm going to start with step by step, and so let's see, step, and of course to begin with, it's going to calibrate the pick and place head and then feed the PCB. So at this point, you can see it located the front end of the PCB. It doesn't have to be completely accurate because the next step is to identify the fiducial points. So the feeding just needs to get it to close enough that it can recognize the fiducial points. And then I'm going to let it run continuously. As you can see, this time, let me just pause it. This time it's picking multiple components at the same time. Because this board is mostly 0603 components, I've set it so that it can pick 3 components like resistors at the same time. And the machine allows you to do vision correction for multiple components at the same time. So you can see here it located 3 components and did vision-based correction on all of them at the same time. Now, for some of the larger components like the shift register, I have reduced the speed to 50%. That generally helps improve the accuracy of the placement. So now it's placing this TVS diode. Okay, so I think the first panel is done. I'm gonna let it continuously run. And it will come back again when the last panel is finished. Okay, so now this board is completely done, and I can just move it back from the conveyor belt and then take a closer look. So overall it looks pretty good. I did notice a couple of components that actually are not perfectly aligned. So this does happen, occasionally. When the pick and place head places the component down, at that moment the component might get misaligned, and that's not something that the vision correction itself can do, because this is after the vision correction. But overall it still significantly reduces the amount of manual adjustment that you have to do afterwards. So overall I'm pretty happy with the machine. The vision correction is definitely a big plus. In addition to that, the added number of components and just the variety of components that this machine can handle, it's also really nice to have. It's pretty nicely designed. The machine can be very powerful, but you don't want to spend forever learning how to use it. So the intuitive user interface and the easiness of the software are also big plus for this machine. Okay, so that's all. Thanks for watching this video.